So let's do a review with just radicals, and we'll be doing more radicals for the rest of the week. But recall, what approximately does the square root of 8 equal? And how do you figure that out? So you don't actually approximate this by figuring out the square root of 8, but using a comparative thing, right? So if you don't know what the square root of 8 is, do you know something that you can take the square root of kind of close to 8? So like square root of 9, right? You know square root of 9 equals 3, so square root of 8 just below 9 equals, well, not equals, but is approximately 2.9. Right? So it's almost a 3. You understand that the radicals and their square roots go in order. So likewise, if I want to know like approximately what the square root of 10 is, it's about 3.1. It's a little over 3 because that's just a little above 9. So you can use this to help yourself out. What we don't want to do now that you guys are using calculators, a lot of you going to geometry next year, you're going to have a calculator all the time. You do not want to use it for every little calculation because you have it in front of you. What will happen is that you become dependent on it, and little things that are you used to do in your head easily take longer because you're using a calculator, and you become one of those students in geometry that I don't have time to finish my quiz, I can't finish my test. Homework is taking so long. Not necessarily that it's a long assignment or quiz or test, but because you do every little calculation on the calculator, okay, that can be a problem. Okay, so with every tool in general and in math, you do not want to just learn how to use it, but learn when to use it. So also keep in mind, I'm going to be checking this today, that when you guys solve, I want to see you use both symbols correctly. So today is, yes, a continuation of yesterday, but I'm going to be focusing on this. Do you know when to use which symbol? I'm going to have you put both. This is called the exact answer. An equal sign is the exact. Okay? And this is the approximate sign. It's like a wavy one. Okay? And whenever you round, okay, that's another word for rounding. So whenever you round a decimal, you should be using the approximate sign. So on a lot of your answers, you can put a box around both of them. You'll have, like right above this, it'll say like c squared equals 8, and then you take the square root of both sides, and then you'll have c equals root 8, and c is approximately 2.9. Yes.
Thank you.
So all these combined, using a close square root to approximate. So if I ask you similarly what the square root of 99 is, my hope is that you don't reach for a calculator, but you use what square root as a reference? Yes. Square root of 100 is 10, so square root of 99 right below 100 is probably about 9.9. Okay? This will speed up calculations, and this is where the real number sense comes into play. And a lot of this helps you out in geometry if you have a number sense. You're not just guessing, you're using some sort of logic to it. Here's another good test, and usually the people that speak the answer right away are wrong, so think about the question before you answer this. Let's say this is 0. And this right here, this number right here is 1 billion. Okay? Where is, on here, where is 1 million? Approximately, if you had to put it. Left side, right side, middle?
Right side.
Left side, like right here?
No.
No? Middle? Right here? No?
On the right side. Yeah, left side, left side.
So you see how basic a question is, but we can't even agree where 1 million is compared to a billion. Now, as you're making your decision, are you coming up with a mathematical reason? Or you're just saying, middle, because it's that way it's half and half and everybody gets some. That's not necessarily mathematics. So we want to be thinking about this. How about, speaking of the middle, what is the exact middle of 1 billion? What's half of a billion? 500 million. That's a good place to start. So given that, where is 1 million? Right there. How many millions are in a billion? 1,000. Right? So be thinking about this as you guys move forward in your math. Some sort of reasoning for your mathematical reason. You went out in the world and you said, yeah, a million's half of a billion. They'll look at you like, we're not going to let you handle any money or any big numbers ever. Which means you're at a cash register. Okay? So you don't want that. You want to have some thought process about what you're saying. Don't just speak the first thing that pops in your mind unless you have a reason behind it. Okay? And that's the first part of geometry is proofs. Can you prove what you're saying? So if you say a million's in the middle, you better have some proof or reason for that, not just, well, I think it's right. But, well, come up with some proof. Well, 500 million's right here in the middle, therefore 1 million would take 500 of these to get to it, so 1 million must be right next to 0. And that really, when you hear a millionaire versus billionaire, you can really see it this way, that there's a big difference. Yeah, both are a lot of money to you, right? But having a couple million, right, as opposed to a couple billion, that's thousands of times the money. Thousands of times. Not just a little bit bigger. Well, now I can buy 2 cars. Okay? Vastly more wealthy. Okay, so please be thinking that, and for everything you do, and I'm really trying to prep most of you for geometry and what's expected. I'm going to be focusing a lot today on this. This is what I'm going to be checking for. If you do every problem right and you have the right decimal but you don't use the right sign, you'll have partial credit. So that's one of the main things I'm assessing you on today, is that you know what this means, when to use it, and how to use it. Okay, very important. It's something to say, well, this is exactly this much, and this is, kind of this much. It's rounded, it's approximate, it's so-so. All right. So let's go to your work today. All right. So let's see how this relates. Recall yesterday that you guys did the Pythagorean theorem, which was based on right triangles only. Okay. And it lets you, given 2 legs, a vertical and horizontal, you could find a hypotenuse or a diagonal. Same thing here. We're just applying this method. So it's very difficult to say how long this is. This is 1, 2, 3, 4. I mean, they're not counting by single squares because it's not horizontal and vertical. So how can you find the length of this diagonal, right, which is kind of like a hypotenuse? Okay. So whenever you want to find the length of the diagonal, kind of like if you wanted to find the size of a TV, remember those are measured by the diagonal, what you could do is you find out how tall it is, find out how wide it is. So same idea here. We can't count this way, but we can count this way. Okay? We can find out how long this is because it's counted by ones. 1, 2, 3, 4, 5, 6. So this side is 6. And this side is what? 7. This is 7. And this is now a right triangle. So we can find the measure of a diagonal the same way we found a hypotenuse. So this is the connection to geometry. Notice the title up front, up top here. This is an actual geometry. There's a lot of algebra in it because it's solving the Pythagorean theorem, which is algebra, but using it for geometric purposes. So you're going to see a lot of this in math and geometry. Things we've done in Algebra 1, and now you have some graphical It's on a coordinate plane. You can find how far apart points are from each other, and so on. So a lot of radicals, by the way, in geometry. We're going to end this week with radicals. The first week of geometry is a whole bunch of radicals: how to add, multiply, subtract, divide, rationalize, Pythagorean theorem, distance formula. That's the last thing we cover. Is the first thing in geometry. So if you're ever asked to find the length of anything diagonal, that's very difficult. But if you can find the horizontal and the vertical, it's a lot easier. So we can do this. We can say, okay, it's 6 squared plus 7 squared equals c squared plus, right? And just solve exactly what we've done before. Once again, something right here, do not reach for the calculator. So, oh, what's 36 plus 49? You can do this in your head. Do the ones first, then the tens digit. So 49 plus 6 is 55. 55 plus 30. 85. Much easier, faster than a calculator. Okay? So keep that in mind. Little simple calculations, you don't want to slow yourself down. It also breaks your train of thought. You get really in the groove of kind of doing a problem. There's a nice flow to it. But then you're stopping every second to try to do the calculator. It really stops everything. You have to restart it. So I'm not saying never use it, but use it sparingly. And then after this point, of course, take the square root of both sides. So c equals the square root of 85. And then do one more step to approximate it. So what is square root of 85 approximately equal to?
9.
Yeah, 9 point something, right? We know square root of 81 is 9, so square root of 85 is 9 point. So at least you know this part. And you might be wrong with the tens digit, the tenth digit. You might say, 1, 2, or 3, but that's what this symbol means. It's approximately. It's close. So if you say 9.2 or 9.3, it's approximate. They're both approximately equal to C. So for all of your problems, you should, or most of them, will have both of these. Now, of course, if the answer came down to C squared is 25, right? Then you'll just have 5 equals C, and there is no approximate because the answer is 5. So remember, you only use this when you're rounding, anytime you round, or approximating. All right, good. So let's go ahead to go to 2. And of course, make sure your answer makes sense. If this is 7, this is 6, it's a little bit bigger than both of those. The hypotenuse or the diagonal is always bigger than the two legs. We know that. But if you forgot to do the square root, you wouldn't put 85 here. You wouldn't say this is 85. Because, let's say this is inches. Like, if you have a side of a triangle that's half a foot, another side that's a little more than half a foot, you wouldn't say the diagonal is 7 feet long, 85 inches, right? Something should stop you and say, that doesn't make sense. 9, yeah, that makes sense. So make sure your answer makes sense. Don't just write it down and say, well, that's what I got, so that's right. All right, so let's give it a shot here. Very similar. Draw your triangle. Okay. What are the two sides? 5 and 2. So what approximately will your answer be? About what? Over here we had 6, 7, and 9. So just approximate. What do you think the answer will be? This is 5 and 2. 5.6, 5 point something ish, maybe 6. So have an idea of what you think it should be based upon previous problems. So if you get some answer that's just way off, you're like, wait a minute, that's not what I thought it'd be. Why not? All right, so let's try it out. Let's do the actual calculation. Very good. We have, remember, 5 and 2 are interchangeable with A and B. I could put 2 squared plus 5 squared. It all comes out to the same number, 27. or 29. All right. So what does C equal? What does C equal? What does it equal? Not approximate. What does it equal? Square root of 29. C equals the square root. So again, know the difference between equals and approximate. So, and now what does C approximately equal to? 5.4%, I'm hearing? Okay. And that's pretty close to what we thought. We said 5.6, 5.4. Okay, so our estimates were right. If we got 7 here, we'd be like, wait a minute, no. That doesn't make sense. All right, and of course, box both of these, please. I want to see both of these boxed. Now, keep in mind, again, I mentioned earlier, when you're learning about a new tool or learning how to use an old tool like we are right now, it's important to know when to use it, such as, number 3, do we need to use a Pythagorean theorem here to figure out how long this is? No. How long is this? 1, 2, 3. Yeah, it's 3. How come we do not need to use it? Common sense, right? But mathematically, what's the difference between these two? 1 and 3.
There's no
Yeah, remember, what is the use of this? It's for finding a diagonal. Is this a diagonal? No. So knowing when to use it is just as important as knowing how to use it. You don't want to take this tool, use it on every triangle for the rest of eternity. It's only when you need to find a diagonal distance. Okay? Find the dimensions of the TV. Same thing on number 4. You know, that's 2. That's all it is. There's nothing to it. No pun intended. What's that?
So the answer to 3 is 3.
Is that how long it is?
Yeah.
Yeah, that's the answer. All right. Now, it'd be great if that's all we had to do today. We'd be done really fast. But you see, starting down here, there is no more graph for you. So you can do 2 things. For the rest of your geometry class, all next year, you could draw a graph for every little single thing, or you can learn how to do this without the graph. Okay, that's the better option. How can we do this without the graph? Okay, if I just give you an x and y, 2 x and y coordinates, those are the coordinates of these endpoints. If I just gave you those, how could you do the same thing without drawing a graph? So let's go back up to number 1. Okay, just watch me up here, and let's make some sense out of this. What are the coordinates for these endpoints? Here and here. What are they? Okay, what are the coordinates? So this one is 1, 3. All right. And this one is -5, -4, right? Now, how can we figure out that it's 6 from here to here just using these numbers? Because if we can answer that question, we don't need the graph anymore. We can use just the numbers. But how can we do that? So how can I figure out on the x-axis, left and right, that it's 6 across using my x values? You tell me. Yeah, so -5 and 1. There's any way to figure out, well, from -5 to 1, it's 6. Okay, so 1 minus -5, that equals 6. So I can get the value of how far it is just by subtracting the 2 numbers. The 1, the -5, 1 minus -5 is 6. Does that work for the y values as well? Yeah, 3 minus -4, what does that equal? 3 3 minus negative 4 is? 2 negatives make a positive. 3 plus 4 is 7. So I can figure out, and so can you, we used a graph and we just counted the boxes 6 and 7, but if I have the coordinates, I can subtract the y's, that will give me one value, and subtract the x's, and that gives me the other value, all without graphing, which is quite nice, especially when you get to the back when it's all decimals. If it's all decimals, it's not quite as easy to count squares, right? So if we can just use the subtraction, and that will help us out. Really, what are we doing? We're finding the distance. How far is it from negative 5 to 1? Oh, it's 6. How far is it from negative 4 to 3? It's 7. And we can do that. We can find the distance by using the difference, which means subtraction. So a big key phrase you will probably hear in geometry a lot is that distance equals difference. Okay? Difference. If you want to know how far is it from 3 to 5, that's 5 minus 3, it's 2. You subtract them, and that'll give you how far apart they are. Okay? And that works over and over and over. Alright, so let's give that a go. Number 7. Let's do it two ways, actually. Let's do a logical way, and let's do it using the difference. How far is it from 2 to 1?
1.
1. 1 squared. How far is it from negative 4 to negative 7? 3. There you go. That equals what? 1 plus 9 equals c squared. 10 equals c squared. So what does c equal? Square root of 10, which is approximately equal to 3.1, which we did earlier. So you notice how we used a little more common sense. Well, how far is it from 2 to 1? That's 1. How far is it from negative 4 to negative 7? 3. Do I care about negatives? No, why not? Because we're going to square it. If I got negative 1 here, I'll square it and I'll get 1. If I got negative 3 here, well, negative 3 squared is positive 9. So the idea that it's positive, negative, distance there's no negative. You're going to square it anyway. So don't worry about negatives if you get them. Now, what if I want to do this using the subtraction? Does that work? So let's see here. 2 minus 1, subtract the x's. Yeah, 2 minus 1 is 1, 1 squared, that works. Negative 4 minus negative 7 squared. Okay, negative 4 plus 7 is 3. Yeah, that works as well. So I can either understand that these are 1 apart, or I can calculate they're 1 apart. Okay, good. And let's see here. Do you guys want to do one more, or let's go to 8? Okay, let's look at 8. Okay, how far is it from negative 1 to 2?
3.
How far?
3. Negative. No?
3 or negative 3?
Negative.
This is distance, right? Can distance be negative? No. So how far is it from negative 1 to 2? 3. How will we get that if we calculated it? Negative 1 minus 2 squared, which does come out to negative 3 squared, but remember, negative 3 squared and 3 squared are both equal to 9. So the negative doesn't really matter. Right? How far is it from 1 to 5?
4.
4. Or we could do 1 minus 5 and square it. 1 minus 5 is negative 4, but negative 4 squared and 4 squared are both 16. So you can see with distance, the whole negative thing, not too important. And here's a good example, I'm glad we did this one, on an answer that you don't need an approximate because the answer comes out to an integer answer. There's no rounding involved. So This is a good example of that. Okay. So I urge you to try this method. If you just like the algorithm approach where you just do the same thing every problem, you'll probably vouch for this one where you just subtract the x's, square it, plus subtract the y's, square it. Please realize that this is Pythagorean theorem. Next year in geometry, you're going to see instead of a C, you're going to see that they're all D for distance. Just realize whether you're finding a hypotenuse or you're finding the length of a diagonal, it's the same exact thing. There's nothing easier or harder. Just one's on a graph and one's a shape. That's the only difference. Okay. In geometry, you see everything on a graph, so you'll see distance D equals. But other than that, about the same. Okay, you guys have the rest of the period. Remember, I'm checking for algebra. Show all the work, but I'm really checking for this. Make sure you have both the exact answer and the approximate answer when it applies. It's like over here, you wouldn't have it because you can't round off 5. Okay? Okay then, go for it, and we'll collect it towards the end of the period. Okay.